Myself, Mr. Wahak GB, working at SBNM Polytechnic, Aurangabad. Today, we are going to start online lectures of SOM. First chapter is Simple Stresses and Strain. Learning outcomes. At the end of the lecture, you will be able to understand what is rigid body and deformable body. You will be able to understand what is equilibrium. You will be able to understand what is stress and mathematical formula of stress. You will be able to understand what is strain and its mathematical formula. You will be able to understand different types of stresses. Equilibrium. What is equilibrium? Any system of forces which keeps the body at rest is said to be in equilibrium. Or when the condition of the body is unaffected even though it is acted upon by number of forces, it is said to be in equilibrium. Analytical conditions of equilibrium are summation of f of x is equal to 0, that is algebraic sum of components of all forces along x-axis must be equal to 0. This is the first condition. Second condition, summation of f of y is equal to 0, that is algebraic sum of components of all forces along y-axis must be equal to 0. Third condition, summation of moment is equal to 0, that is algebraic sum of components of all forces about any point in their plane must be equal to 0. These conditions of equilibrium are used to find out unknown forces. Rigid body. What is a rigid body? Rigid body is defined as a body which are fixed in position relative to one another even when subjected to a number of forces. Rigid body do not deform when subjected to a system of forces. In fact, no body is perfectly rigid. Every body deforms slightly under the action of forces. Hence, a rigid body is a theoretical concept or theoretical concept or imaginary concept. Deformable body. Change in size and shape of a body due to external force is called deformation. A deformable body undergoes change in dimension of a body, that is change in length, change in width, change in thickness, change in volume. Stress. What do you mean by stress? Whenever some external force acts on a body, it undergoes some deformation. As the body undergoes a deformation, its molecules set up some resistance force or resistance to deformation. This resistance per unit area to deformation is known as stress. Mathematically, stress may be defined as the force per unit area. Stress is denoted by sigma. So, sigma is equal to P upon A, where P is load or force acting on a body and A is the cross-sectional area of the body. Now take an example. a tensile force is applied on a body. You have a body which is applied by two force at the two end of the body. What happens? The body tends to move to left or right side of the body, but the body does not want to pull or elongate in both direction. The internal fiber of the body material will start resisting this load. All the fibers will try to resist the pulling force. Therefore, summation of all internal forces is equal to external force or external load. Therefore, sigma is equal to R upon A. Sigma is equal to R upon A, where R is the resisting force upon cross-sectional area, but R is equal to P. The internal force is equal to external load. Therefore, this formula is sigma upon P by A. Units, SI units. Sigma is equal to P upon A. P is the force of Newton and A is the area. It is meter square. So sigma, unit of sigma is equal to Newton per meter square. But in engineering, meter is not the perfect. Mm is the perfect. Therefore, we have to convert it into mm. Now conversion factor is 1 meter is equal to 1000 mm, that is 10 raised to power 3 mm. Now 1 meter square is equal to meter square means meter into meter. Therefore 10 raised to power 3 into 10 raised to power 3, 10 raised to power 6 mm square. This equal to 10 raised to power 6 mm square. This is the conversion factor. Now 1 Pascal is equal to 1 Newton per meter square, and 1 Newton, now meter square is converted into mm square. Therefore 10 raised to power 6 mm square. Now cross multiplication, we get 1 Newton per mm square is equal to 10 raised to power 6 Pascal, and 10 raised to power 6 means mega. Therefore 1 Newton per mm square is equal to 1 megapascal. This is the conversion factor. Types of stresses. Though there are many types of stresses, yet the following two types of stresses are important from the subject point of view. First one is the tensile stress and second one is the compressive stress. Tensile stress: when a body is subjected to two equal and opposite pulls and the body tends to increase its length, the stress induced is called as tensile stress. Suppose a body is elongated or tensile force is applied. Firstly, the length is L. After applying the tensile force, the body changes, that is the length changes, L plus delta L. The force is increased and is elongates. Therefore the tensile, after the body in tensile, the length will increase to L plus delta L. Tensile stress will always create elongation in length and is always positive. Tensile stress may be denoted as sigma T. types of stresses. Compressive stress. When a body is subjected to two equal and opposite pushes and the body tends to shorten its length, the stress induced is called as compressive stress. A force is applied, a compressive force is applied on a body. Starting length is L. After compression, the length will be decrease, and the formula is L minus delta L, that is the shortens or reduction in length. Compressive stress will always create reduction in length and is always negative. Compressive force or compressive stress will be denoted by sigma B. Strain. What is strain? Whenever a force acts on a body, it deforms some deformation, or whenever a force acts on a body, it undergoes some deformation. This deformation per unit length is known as strain. Mathematically, strain may be defined as the deformation per unit length. Strain is small m, denotes by small m. Strain is denoted by small e. So small e is equal to change in length upon original length, where delta L is the change in length of the body and L is the original length of the body. Now strain has positive values and negative values. Whenever a tensile force acts on a body, the body undergoes positive deformation. Now small e is the strain. Strain is equal to change in length upon original length. Now, for example, a tensile force is acted, starting length is L, and after tensile force is act, the length will be increased, that is L plus delta L. Now E is equal to change in length upon original length. Therefore L plus delta L upon L get cancelled and plus delta L by L is remaining. Therefore E is equal to positive delta L plus L, positive deformation. Therefore tensile force makes positive deformation. Whenever a compressive force acts on a body, the body undergoes negative deformation. Again, the small e is equal to change in length upon original length, where delta L is equal to change in length of the body and L is the original length of the body. Now take an example. A compressive force is applied on a body. Then when applying our body, the starting length is L, but applying the force, compressive force, the decreasing or shortening of a body occurs, that is L minus delta L, that is reduction in length. Now E is equal to change in length upon original length. Therefore, change in length L minus delta L upon L. Now L get cancelled and minus delta L upon L remains. Therefore, compressive force acts on a body, creates negative deformation. Summary: any system of force which keeps the body at rest is said to be in equilibrium. A rigid body is defined as a body which are fixed in position relative to one another even when subjected to a number of forces. Change in shape and size of a body due to external force is called as deformation. Stress may be defined as the force per unit area. Types of stresses: tensile stress and compressive stress. Tensile stress: when a body is subjected to two equal and opposite pulls and the body tends to increase its length, the stress induced is called tensile stress. Tensile stress will always create elongation in length and is always positive. Tensile stress will be denoted as sigma T. Compressive stress: when a body is subjected to two equal and opposite pushes and the body tends to shorten its length, the stress induced is called a compressive stress. A compressive stress will always create a reduction in length and always be negative. Compressive stress will be denoted as sigma B. Strain may be defined as the deformation per unit length. Strain has positive values and negative values. Whenever a tensile force acts on a body, the body undergoes positive deformation. Whenever a compressive force acts on a body, the body undergoes negative deformation. That's all. Thank you.